Hi everybody, I am Anthony Santosh, Assistant Professor of Chemistry in St. Joseph College of Arts and Science. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Now we are going to discuss some of the problems, question and answers or objective types in ideal gas equation, using ideal gas equation, and after that we will discuss one problem to solve the variables in ideal gas equation using ideal gas equation and van der Waals equation of state. We will see both the things now. Okay, so the first question here is, which of the following term does not involve in ideal gas law? Which of the following term does not involve in ideal gas law? So let us go into the answers first. Option A, pressure. Option B, volume. Option C, temperature. And D is time. So first we should know what is ideal gas law. Ideal gas equation is the one PV is equal to nRT, or PV is proportional to RT. P is pressure we have here, V volume we have here, temperature we have here, time we don't have the variable of time. So the question is, which of the following term does not involve in ideal gas law? So it does not, time is not present in ideal gas equation. So D is the answer. Next question is an important question which is usually asked in competitive examination with twisting the variables of ideal gas equation. So let us see one type of the question. So what is the shape of pressure and temperature curve, or pressure versus temperature curve for ideal gas? So without the graph the question may be asked, or with the graph the questions may be asked. So here the question is asked without the graphs actually. So what is the answer? Straight line, parabolic, hyperbolic, and ellipse. So these are the options for pressure versus temperature curve. So pressure versus temperature, we actually, I don't want to confuse now. When we have the value pressure and temperature, so we have pressure and temperature. When we increase the pressure, when we increase the temperature, the molecules are getting expanded. They will move here and there, and when they expand from their size, definitely there will be an increase in the pressure. So there is an increase, a linear relationship, a directly proportional. Pressure and volume, pressure and temperature, they are directly related. So what should we do? What we will be having a straight line at a constant n and v, at constant number of moles and volume. When we plot the pressure in the vertical axis and the temperature in the horizontal axis, we will get a straight line like this. So according to the first question, the answer will be option A. Straight line is the answer. The same question can be asked. The next question is of the same concept. what is the slope of volume versus temperature curve for ideal gas? So the answer here is, we can assume how the volume and the temperature are related in ideal gas equation, that we should know. So we have here how the volume and temperature are related. They are directly related. So let us imagine, when we take some water, when we increase the temperature, it will boil, and here we are considering the gaseous molecule. So if we have a closed cylinder and if we increase the temperature, what will happen? Automatically the molecules will move. They will move here and there, and also they will expand. So when the temperature increases, automatically the size of the molecule expands. So both things are directly related, as in the case of pressure and volume. Pressure and temperature are directly related. Likewise, volume and temperature directly related. So we will get the same type of answer. So when we plot the values, when we have volume in vertical axis and temperature in horizontal axis, at a constant number of moles and pressure, we will get a straight line like this. Okay, so according to the same concept, as per the same option, if we have, we will get the same answer. Option A. Here answer is A. Clear? Next question also falls with the same concept. What is the shape of pressure and volume curve for ideal gas? Option A, straight line. Option B, parabolic. Option C, hyperbolic. Option D, ellipse. So we have here how volume and pressure, they are related. We should know the concept. Here, if we take the volume cross over when we cross it cross over the equal symbol, 1 by V we will get 1 by V. P is proportional to 1 by V. So what is this? It is both the variables pressure and volume are inversely related. Both the values are inversely related. So when we have this kind of inversely relation, when we plot the pressure in vertical axis and when we plot the volume value in horizontal axis, what will be the graph? How we will be getting the graph? The graph will be a hyperbolic graph. The graph will be a hyperbolic graph. So this is the hyperbolic graph. So the answer is answer C, hyperbolic. Okay. Now let us discuss the next question. Which of the following is not true about ideal gas? Which of the following is not true about ideal gas molecules? What are the options? For option A, they have negligible size. Option B, they do not have attractive force. Option C, they do not apply pressure. Option D, they move in random motion. So these are the options for the question which is not true about ideal gas. And we should know we should know the concept first. If we know the concept or explanation, then we can easily find out the answer. So the explanation here is, they apply pressure to the walls of the container. The gaseous molecule, the ideal gaseous molecules are applying pressure to the walls of the container. So by knowing this explanation, we can find the option is in an easy manner. Okay, so they have negligible size, they do not have attractive force, they do not apply pressure, they move in random motion are the options. So with the explanation, they apply pressure to the walls of the container, we can easily find out the answer.